Hi, welcome to this lesson on calculus, finding tangents to functions. Let's have a look at question 3 here. So we want to find the equation of the normal line to the function negative 5x squared plus 2 at the point negative 1, negative 3. So normal line, if we go back to the properties of straight lines that we saw at the beginning here, normal lines are lines that are perpendicular to tangent lines. Okay, so if we find the equation of the tangent line first, then we need to find the equation of the normal line, which is essentially going to have a reciprocal negative gradient, as we saw in the properties of straight lines. So for example, if we find that the gradient of the tangent line, or the equation of the tangent line looks something like this, then the normal line is some line that goes perpendicularly through here. So that's y normal. Okay, so let's start off by finding the tangent line, because we know how to do that using calculus, and then we will find the normal line using our properties of straight lines. So first of all, the tangent line, I'm going to denote by y tan, is mx plus c, where m here, the gradient, is defined as the derivative at that point of contact, negative 1. So first of all, what is the derivative? Well, if I use the power and sum laws here, the derivative will give me negative 10x. Okay, so now if I evaluate at negative 1, I get negative 10 times negative 1 is just positive 10. Okay, so far my y tangent is 10x plus c. Now I can substitute my point of contact, which is negative 1, negative 3. So let's just put a rough sketch together so far to see what this thing looks like. Okay, because this is a quadratic function, we know how to draw these. So negative 5x squared, so it's going to have a sad face shape with a maximum turning point. And because there's no b coefficient here, it's going to turn at the y-intercept, which in this case is 0, positive 2. So it's going to look something like this. Okay, and it'll have some x-intercepts as well that we could work out. Okay, but for our purposes, what we want is, at the point negative 1, which is, I want to say over here, right? Well, let's actually make sure, right? Because we can work out what the x-intercepts are. So how do we work out the x-intercepts algebraically? Well, that means we solve f of x equals 0. So that gives us negative 5x squared plus 2 equals 0. So if I bring everything across, I have positive 5x squared minus 2 equals 0. Then I have x squared equals 2 over 5, right? If I bring the 2 across and then divide both sides by 5. So now I get x equals plus or minus the square root of 2 over 5. So let's just get an idea of what that is. So I'm going to take square root of 2 over 5. That's going to give me 0.63. So it's going to be plus or minus 0.63. So this is negative 0.63 and this is positive 0.63. So negative 1 is over here. And then the y value here is negative 3. So there's that coordinate, negative 1, negative 3. So what are we looking for? Well, first of all, we're finding the equation of the tangent line at that point. Okay, so far we have it as y equals 10x plus c. Right, to get c, so I'm going to find that right now. If I substitute, I'm going to have negative 3 equals 10 times negative 1 plus c. So if I bring over that negative 10, I get c equals positive 7. So 10x plus 7. And that makes sense. You can see it cuts the graph quite high up there for that tangent line. Now we want the normal line. So the normal line at that point of contact is going to be a line that cuts through there perpendicularly to our tangent line. So this is also another straight line. Y equals mx plus c. And I'm going to call this y sub capital N for y normal. Now the gradient of the normal line is going to be negative 1 over the gradient of the tangent line. That is by the special properties of perpendicular lines. So it's going to be, instead of positive 10, it's going to be negative 1 over 10. So far we have y sub n equals negative 1 over 10x plus c. And again, I can use that same point of contact, right, to find my y values or my c value. So in this case, it's going to be negative 3 equals negative 1/10 times negative 1 plus c. So I'm going to have negative 3 equals, that's going to be 1 over 10 plus c. And then to solve for c, I'm going to subtract both sides by 1 over 10. So if I simplify that, it's going to give me negative 31 over 10. So there's my equation of my normal line. Negative 1 over 10x minus 31 over 10. And that is the equation that we were looking for. The equation of the normal line, not the tangent line. But can you see we had to work out the tangent line first to get the normal line? All right, so quite an involved question, but make sure that we understand the terminology correctly from our straight lines. Awesome. I'll see you in the next one.